All right, so this lesson is going to continue with more trigonometry, more sine, cosine, tangent, and specifically tonight we're going to talk about a new rule that you haven't learned yet. It's something called the law of sines. So all we're going to be talking about today is sine, but we're still going to need to know everything we knew about sine, cosine, and tangent. So the law of sines. Now, down here, this looks like a right triangle. It looks like it has a 90-degree angle here. And you're pretty comfortable with these by now because we've been doing Pythagorean theorem where we find all the sides. We've been doing sine, cosine, and tangent. We can find all the angles. We can find all the sides no matter what. But we're going to change this now and make this just a random triangle. So it's no longer a right triangle. It's just a random triangle. So I'm going to label this triangle. It's going to be triangle A, B, C. And then you know that we've been labeling the sides. Opposite of the capital A is the little a, opposite of the capital B, little b, and then little c down here. And what I'm going to show you is the law of sines, which allows you to take any triangle and use what you know about sine, opposite over hypotenuse, to figure out missing sides and missing angles of any triangle. So what we're going to do is a little trick. It's not really a trick, but it's something that you may not have thought to do. So, all right, so I'm going to take this triangle and I'm going to split it right here and make a nice perpendicular line here. It's perpendicular to the base. You should remember that this would be the height of this triangle. So we're going to call it h for the height. So now if you look at just this triangle over here, just this little one on the left, and I asked you about angle A, which is right here, you could tell me that the sine of angle A equals the opposite over the hypotenuse, B. And if I asked you about this little triangle here on the right, you could tell me that the sine of angle B equals the opposite, H, over the hypotenuse, A. So I have these two little equations here that are about the sine of two of the angles of my triangle that's not a right triangle. So what I'm going to do is manipulate them. So I'm going to move stuff around to where they both say H equals. Because if they both said H equals, then they would have to be equal to each other. So I'm going to multiply both sides by B. And I'm going to get B sine of angle A equals H. And then I'm going to multiply both sides of this one by A. So I'm going to get A sine of B equals H. And now you see I've made both these equations equal to the height. So the height of this triangle is B times the sine of angle A, and it's also A times the sine of angle B. So that means I can take this, and I can make them equal each other, just like this. So I can say B sine of angle A equals A sine of angle B. And I could have done this with angle C instead of angle A or angle B. We could have drawn our height in like this, and we could have done it lots of ways. But we'll just do it with A's and B's for now. What I'm going to do now is also something that you probably don't think to do very often, but it's something you can do. I'm going to divide both sides here by A. And I'm doing this because I want to have both the A's on the same side. I want to put both the B's over on the other side. So right here, those go away. And I'm just left with B sine A over A equals sine B. And then I'm going to divide both sides by B. So I can just do it like this. Divide by B, divide by B. Those will cancel. And what I'm left with is the sine of A over A equals the sine of B over b. Okay, so basically I just did a little algebra, a little manipulation to realize that the sine of angle A divided by A equals the sine of angle B divided by B. And like I said, I could have done it with the C, and I would have wound up with the sine of angle C over C. Now this little formula looking thing that I wrote out here is called the law of sines. Okay, so this is what you're learning today. Law of sines. The law of sines can't be used every single time, no matter what the scenario. It only works under 3 specific scenarios. And those 3 specific scenarios are when you're given an AAS pattern, when you're given an ASA pattern, or when you're given an SSA pattern. You should remember these two, angle, angle, side, and angle, side, angle. These are 2 that we've already learned. The SSA pattern is one that originally I told you not to worry about, not to think about. Remember, if you spell it backwards, it spells a bad word. So now you want to kind of add the SSA pattern to your list of things that you recognize. And I'll show you how this works. We're going to start out with an AAS pattern. I'm going to go back up here, and we're going to do the AAS possibility here. So I'm going to draw a triangle EDF, and I'm going to tell you that from E to F is 18. The measurement of angle E is 32 degrees, and the measurement of angle D is 105 degrees. And your instructions are to find the length of DF. So that's your instructions. Now, when you look at this, that means that we're trying to find this distance right here. Now, if we think about our law of sines that we just wrote down, what it says is that the sine of an angle over its opposite side equals the sine of another angle over its opposite side, and that's equal to the sine of the other angle over its opposite side. So I'm going to write that down so you get practice with it. We're going to write the sine of an angle over its opposite side equals the sine of another angle over its opposite side, and that equals the sine of the third angle over its opposite side. Now, our instructions say to find DF. So I know for sure I'm going to have to use this. So I'm going to definitely use that one. Then when I look at my triangle here, the only angle and opposite side that I have both numbers for is this 105 and this 18. This is angle D, is 105, and EF is 18. So this is the other piece of the law of sines I'm going to use, and I'm not going to use this one at all. It might seem a little weird at first, but what I'm going to write down now is the sine of angle E. So I'm going to write sine 32 over, now DF is just going to stay DF. That's this side over here. I don't know what it's called, what it is, or how long it is. So sine of angle D, which will be sine 105 over EF, which is 18. And now I've set up a very easy cross multiply and divide proportion. So I'm going to cross multiply here and get DF times sine 105 equals 18 times sine 32. Well, we've been doing enough of this for you to probably understand that we're just going to do this, divide by sine 105, divide by sine 105. So I'm going to know that the length of DF is equal to 18 times the sine of 32 divided by the sine of 105. And you can put all that in your calculator in one shot. You just have to do 18 sine 32 divided by sine 105. The key is that you get this parentheses in the right spot. As long as you get this guy in the right place, everything will come out nice and pretty. So df is approximately equal to 9.87. Okay, so that's our first case. That's our first possibility, is an angle-angle side triangle. And we came up with df is equal to 9.87. I'm going to slide down here, and we're going to set up the other two possibilities. We'll first do the ASA. So I'm going to draw a triangle. It's going to be triangle ABC. And we're going to have angle B is 67 degrees, angle C is 44 degrees, and the length from B to C is 20. So you see here we have an ASA pattern, and we're going to find AC. So we're going to find out how long this piece up here is. So think about our law of sines again. It says that the sine of an angle over the side opposite of it is equal to sine of an angle over the side opposite equal to the sine of an angle over the side opposite. So practice writing it down. So sine of A over BC equals the sine of B over AC equals sine of C over AB. And then I look and see which ones I'm going to use. I need to find AC, so I know this one is going to get used. Now, you may look at this now and think, well, okay, that's great. I got sine of B, so sine 67 over this, but I don't know an angle and its opposite side. But you do. You can figure out what this angle is very easily by adding these two together. So 67 plus 44 equals 111, and then we subtract that from 180. We get 69 degrees. So this is, even though it wasn't given to us, like completely given to us, it's still pretty easy to figure out that that's 69 degrees. So the sine of A over BC is given to us. This sine C is over nothing. We're not going to be able to figure anything out about it. So we'll rewrite all this. So we'll write sine 69 over 20 equals, and then the sine of B, 67, over AC is what we're trying to find. So I'm going to cross multiply. So I'm going to do AC times sine 69. AC sine 69 equals 20 sine 67. We'll divide both sides by sine 69. Divide by sine 69. And I'll get AC equals, and I'll, in my calculator, do 20 sine 67, close the parentheses, divided by sine of 69, also close that parentheses, and I'll get that AC is approximately equal to 19.72. Okay, so we're going to keep practicing it. We're going to do one more. We're going to do the last scenario where you could have an SSA. So we're going to draw a triangle, triangle RST. All right, and we're going to know that R to T is 5. We're going to know that the measure of angle T is 75 degrees, and we're going to know that R to S is 7. And again, this is one that you haven't done before, this pattern. This goes S, S, A. Or if it helps you remember it, if it makes it easier, I mean, all I care is that you get the right answer. So if you need to go A, S, S to make it stick in your head, that's fine. We're going to find the measure of angle S, which is right here. So this is a little different. We're going to find an angle this time instead of finding a side. But you can always find angles or sides using trig ratios. So it shouldn't be that big of a deal. First thing we're going to do is write down our law of sines. The law of sines says that sine of R over ST is equal to sine of S over RT is equal to the sine of T over RS. Then we look, we need to find the measure of angle S, so we're definitely using that one. And we know that T, we have angle T and we have the side opposite of it, so we're also using that one. So this guy is not getting used. So I'm just going to write down my equation or my proportion. So sine S, I don't know what S is, over RT, which is 5, equals sine T, sine 75, over RS, which is 7. Cross multiply, so I get 7 sine S equals 5 sine 75. Now this might cause some of you a little hiccup here if you're not quite sure what to do, because remember, we're trying to find angle S. This is what we're trying to find. So we want this to stay where it is. Now we can't divide it by sine. We need the sine to help us find the angle in a minute. So we're going to divide it by 7 because we want to get rid of that 7. So now I have sine S equals, now 5 times sine 75 divided by 7 is equal to something. Okay, so you type that in your calculator. 5 sine 75, close your parentheses, divided by 7, and it equals 0.69. So how do we find out what S is? Well, we do remember, we do the inverse sine of 0.69. We find out that that equals 43.6. So that means that the measure of angle S is approximately equal to 43.6 degrees. And that is how you use the law of sines. Don't worry, we're going to practice it, but you are going to have to memorize it. So any questions you have, make sure you wrote them down and ask tomorrow.